Something I just thought of, the next door, she's got to move the tables because the class she teaches, I'm actually teaching it next semester. It's going to be like a help class for calculus students, so who need like extra reminder of what pre-calculus is. So she's moving all the tables so that they can work in groups better. So I was thinking, I should have just had all of us go help her. Be done in like a minute. And I was walking by, I'm like, why didn't I ever think about that? And I don't know if you guys even would have. Let's go there. Ain't my job. I wouldn't, like, what could I say?
We'll go do it.
Yeah. Sounds like she might be done. It's exactly the best time to realize you can help is when they're already done.
Is test 3 going to have this many questions?
No.
More? Okay.
Yeah, don't freak out. That practice tests, I think, almost always are a little longer because there's so much stuff, and then I whittle it down to whatever. So what exactly will be on there, you'll find.
The easiest.
Oh, is that door? What happened?
No, they just didn't push hard enough.
Yeah, you gotta be sort of.
Eat your vegetables. And after test 3, there will be an opportunity for correction.
No, I don't think there are corrections on the final.
No corrections on the final, correct?
No,
What we get
it's
is what-
appropriately named.
Fair enough. It would be foolish of me not to ask.
So what do you guys think? You guys, real quick question before I go back to proving that thing. I let you guys make corrections. A colleague of mine thinks that causes students to not take tests as seriously.
Foolish. That is foolish.
I agree, especially because I've had students misunderstand.
That's what I'm saying.
I don't give all my points back.
Yeah, exactly. So
Yeah.
it's not
In
that-
fact, the points I give back aren't enough to save somebody who isn't doing
Exactly.
the minimum of what they should do.
I have reviewed a test for the corrections and learned it better because I'm going over the problem again.
Good.
Yeah.
Yeah.
Yeah, I think whoever said that is not.
Because I want you.
Because in life, you don't have, like, if you're doing, like, work stuff, you don't have one chance to do it, right? And if you don't. Yeah, who's the hater?
I'm not. Doesn't matter.
Dawson's hat.
I have a lot of disagreements, and I am open to the fact that I don't have the best way to do everything.
Sure, but
It's interesting though, that when you teach, you have all these different philosophies of different people, and some of those are just what jive with you.
yes.
So there's certain things I could never do because it just isn't something that's in my wheelhouse, right? So if I try to do it, it would be very unnatural. Does that make sense? So I always think that there's a certain level of teaching that you can't teach.
Yes.
It has to be something in you.
Within
And then
you.
from that, you can do all these different things that kind of live within you. So it's anyway, enough of that.
Also, any opportunity to give an opportunity is a well-used opportunity. You know what I mean? Like, you can't go wrong by giving somebody.
Yeah,
I mean, like you said, it's not enough to say.
I don't want somebody to just get a test back and throw it away. I want there to be a reason for them to look at it.
I would
and
literally throw
rethink
these
about it.
tests
Yeah,
away if
yeah,
there was no, I like that one.
yeah. Just coming back to this real quick. This is related to number 2 on the quiz. I think I proved this before, but if you look at it one way, my claim is that if I just add these wrong, like Mason says, which I like, so I just add them wrong, I get a fraction that is between them, which means that for one thing, it's gotta be bigger than this guy's. This is his school. So a concrete example would be 4 11ths and 7 17ths. I just had it. Let me make this, sorry. Let's make this 12 cents. Okay. If I add these straight across, I get 16 over 28, which would live between the two of them. And I know that reduces, I don't care. Just if you add straight across, which you never can do, it's not the answer to any simplification question. This is its own thing.
I got confused because the number is greater than any of those two fractions, but the confusion was that just because the number is greater doesn't mean the fraction is.
Yeah, there's a question in there in the homework about if I increase the denominator, what are the numbers doing? Are they getting bigger or smaller?
Smaller.
And if I increase the numerator, what are the numbers doing?
Bigger.
Bigger. But if I increase both numerator and denominator, it's not exactly immediately obvious what's going on. Does that make sense?
Yes.
So sure, the top and the bottom are both bigger than both, but both of them got bigger, so overall they kind of averaged out. Does that make sense?
Yes.
Okay. Does anyone need to see the proof of that, or are you guys okay? You guys, do you care one way or the other? I think I did this once before.
You've done it, yeah.
Yeah, so. Real quick, I'm sorry. Kaylee. Callie, oh, sorry. I knew somebody named Kaylee, and it's just stuck in my head.
Let's just have to ask that.
Stabler, is even got Stables.
That's a miracle.
Shano. I think that's everything. Okay, that's everybody. Okay. So, okay, so, was there any active questions? I don't think so at the moment. So today, of course, is review day, just like always, yes.
Can you show the strategy that you wanted us to use in number 4, where it was like 7/4 times?
Oh, yeah.
Oh.
So real quick, hold on. If I ask you, what's up? Oh, go. What's 2 times 17 times 50? What would you do first? 2 times 50, hell yeah, I would. Because then 100 times n, they just throw some zeros on, yes? Is that cool? So if I gave you 5/6 times, I think that's actually a problem. It doesn't matter, just 8/17 times 19/44 times 17/8. Now some of you guys, I understand, you multiply this stuff out, then you're, oh my God. But compatible numbers kind of comes into play. So what's true about 8/17 and 17/8? Reciprocal. So what do you get when you multiply them?
Cut each other out.
So the answer is? You with me? So it's the idea of if I have nothing but one operation, multiplication or addition, I can add, multiply, whatever order I want to. So of course I'm going to move the stuff around that kind of go together, right? Yes.
Can you show me please where I was wrong with mine? So see, I guess I didn't have to add all that, is that what
Oh,
it worked out?
yeah, because you didn't really show me the strategy. This is what I needed to see, an understanding of like compatible numbers. Do you see what I mean? And that didn't really show that to me. Yeah. Yes.
A homework problem. I have no idea what this child's even trying to say.
Oh.
5.1B51.
5/1 V51.
Yeah.
So this says. Too bad, Joe. Oh, if A divides M and A divides N, then A divides blah blah blah. Oh, okay, guys. This is perfect.
Is this a good question?
Yeah. So if A divides N plus M, what does that mean about these statements?
That they go into both.
If you're curious.
That they go into both, right?
That's the question. Does it? Are those true? If I'm giving you this is true, can you, so, does 3 go into 15?
Yeah.
So what this would say is, I don't care how you break 15 up additively, you're claiming 3 goes into the pieces. Is that true?
Not always.
So 3 goes into 15, correct? Okay. So if you believe this is true, if you believe that if this is true, then these are true, that means no matter what way you break 15 up, 3 goes into each part. Do you see that? So like, I could break up 15 as 6 plus 9. There's 3 going to each. Yes, and unfortunately one person did that and stopped and said, looks good. I'm like, all you had to do was one more, like 7 plus 8, that goes to shit. 3 doesn't go into 7, 3 doesn't go into 8. Why does it make sense? Because division is about multiplication, not about addition, right? So, if 3 goes into, if 3 goes into n times, if A goes into n times m, that's a more interesting question. But real quick, I want to make sure everybody's with me. Which problem was this again, Mason?
5.151B.
51B51. So it tells you a student thinks that if this is true, then these are true. And the easiest answer for something that's false is to give a counterexample. 3 goes into 15, but 3 does not go into 7, 3 does not go to 8. You guys?
So wait, was that true or no? This one was true, correct?
No. That's a counterexample. So what does it say? Remember, this says that if 3 goes into a number, then it also goes into each part of the number additively.
Okay.
And sure enough, 8 plus 7 is 15, but 3 does not go into 7, 3 does not go into 8. So it is not true that if a number goes into the sum of 2, it doesn't have to go into either one, right? The easiest way to see that is take any number, give me any number.
17.
17. 17 divides 17, correct?
Yes.
So any number, do 1 plus something to get that number. Does 17 go into either one of these? No. So any number, give me 87. That divides 87. Yes? But it doesn't divide 1 and it doesn't divide 86. That's no matter what the hell number you give me, if I break it up as 1 plus something to equal that, nope, it doesn't go into either one of those. Maybe. Those are definitely the weirder questions, and of course they are. You're going to get some weird-ass questions from your students. And to be ready for those, you always have to be a few levels above what they're doing, right? Yeah. Sorry, go ahead.
We're done with that problem?
Yeah,
Okay.
as far as I know.
I'm looking at practice test 3.13, and it says write 9.587 in words. It would be 9 and 587 thousandths. Wait.
Well, 9 and, now how do you say 587? 587 thousandths. I love it. Don't forget the lift. Right? Decimals have a lift. Yes, Marlena.
Can you explain how to demonstrate fraction?
Sorry. How to demonstrate on an underline.
Yeah.
Okay. There were multiple answers I accepted. I'll tell you the one I had in mind, and then I'll tell you what I accepted. So if I wanted to see, what was the problem I gave you?
Is this on the practices?
No, it's on the quiz.
5/8 minus 1/8?
Okay, so let's say I want to do
I got the 7 one.
3/5 minus 2/5, right? Just to do a problem like that. So the way I was thinking in my head, get a number line. You go up to 1. How many places you got to break this up into?
5.
All right, so I want to do 4 cuts. 1, 2, 3, 4. So this will be 1/5, 2/5, red 5th, blue 5th. Okay. Somebody got that thing. Back to the left. 3/5 minus 2/5 is 1/5. So that would have been perfect, right? And not even that, I'm sorry, I don't mean to say that. Just the way I thought of it. You could do kind of like to count on, but count backwards. So you could do, you could start at, 3/5, and then go back 2/5, and then stop at 1/5, right? Yes.
I did 1, 2, 3, 4, 5, like all over 7, and then I just don't know where I was going.
Oh, I thought that was like a one
No,
there.
that was like the end of the line.
But like, where's the answer on this? So I think you were sort of showing the distance between them, which is a valid way to think about subtraction, but when we're doing this number line thing, it's all about motion, right? So you wanna start, either go forward this much and then go backward this much. And then where you end up is the answer.
I did the backwards without going forward.
But you didn't, it's kinda like if you did this problem and you found these two, that doesn't really show the answer. Yeah, does it make sense? So, this is, the distance between these two is the answer to this question. But it doesn't really flow with using a number line. Number lines, I normally want to talk about how far do I move, so I want motion to be a part of it. Yeah. So a couple things there. I need to see that, and I also wanted to see kind of like what you did leading to the answer. Yeah. You know, don't forget this. If you make corrections to a quiz and you do better on the test, what can happen? Do you guys know? This has already happened a few times. Your quiz grade can go up. So like, let's say you have a horrendous day and you come in for the quiz and it doesn't even matter what you know, you just have this shitty day and you got a 40. Then you take the test and you do all the corrections, get them all right. You take the test and you get a 78. Your quiz becomes a 78. You understand? If you got half the corrections right, I average it halfway with the test. Everybody with me? If you got a lower grade on your test, nothing happens. I'm not gonna make it go down. That would be really evil. You guys kinda with me?
Can we do simplified ones?
Sure.
Both in D and C?
Quiz.
Quiz 4?
Sorry?
For quiz 4? Yeah, cause one of them, the whole number, it was what threw me off.
Number, which one? Sorry?
3.
3, okay. I gave back all the quizzes. I don't really have a problem
3
anymore.
D and C.
It's the next
Number 4, okay.
No.
B and C?
Yes, sir.
Oh, so B was all about reducing before you multiply, right? So if I had like 81 over 48 times, what you got, Jeff? I don't know, Jeff. Let's do 80 over 27. Let me go ahead and do this. I'm not used to putting an X. You could multiply tops and multiply bottoms. Now, some of you guys were cross-multiplying. The only time you ever cross-multiply is if a fraction equals a fraction. Then you cross-multiply. There are other places you can kind of use cross-multiplication creatively to do something. But if I'm telling you multiply two fractions, you multiply across. Why is not what I want to do first here?
Because the number's gonna be too big.
The number's gonna be huge. Now, that's not really, if there was nothing that would reduce, I just have to get those big ass numbers. But the beautiful thing then would be, I'm not gonna waste any time trying to reduce it. I need you to understand. If nothing reduces now, that means nothing will reduce in the answer. I'm done. But if I just multiply, then I gotta go, can I reduce these large ass numbers? Oh shit, you know. Much easier to reduce it the way it is. Did you?
So we cross-reduce.
Cross reduce.
Okay.
Because what's the only time you can cancel something? If the operations are opposite. So if you're up top, you're multiplying. If you're down below, you're dividing. Opposite operations. Does it make sense? What's 2 times,
Are we about to cross reduce right now?
I mean, yeah, you cross reduce. So real quick, let me make a smaller problem. 2/5 times 10 fourths. This would be 2 times 10 over 5 times 4, correct? Which would be 2 times 10 over 4 times 5. Is that cool? So then, see how you reduce the 2 and the 4? So why not just do it here? That's all. That's all it is. If it's up top and down below, they can cancel, because then they're opposite operations.
Thank you.
So here, what happens here? Can you guys see what happens here?
27.
By the way, real quick, what really helps you out? What's 8 plus 1?
9,
It's 2 plus 7.
9.
I mean, so don't feel like the divisibility rules are just something you need to answer my crazy ass questions. No, they're just generally good to know shit in your life. Do you understand what I'm saying? Okay. So 9 goes in. 9. 3 times. 9 times. Keep going.
1 and 0.
Good. Okay. You guys with me? What goes into these?
4.
Let's do 8, right? 6 and 10, and then 2, so it'd be 3 and 5. Is that cool? And then
15. Crossroads.
No, that's 1.
1.
so what's the answer?
5.
5 over 1, so 5. Okay, cool. That was even better than I intended it to be. Does it make sense? And in fact, if you kind of miss some reductions, okay, multiply it and then notice you can reduce what you have. So you can reduce in as many steps as it takes. Right? So I could have realized that 27 goes into 81, but that's not an immediately obvious fact. So I had to do a couple steps. No big deal, yes.
Quiz.
I'm sorry, any more about that? Yes.
If you're dividing, do you,
Oh yeah, so the first
reduce
step?
it, or simplify it first and then reduce it?
No.
Or
Oh,
flip it, sorry.
You gotta flip it first, yeah.
And then you reduce.
So a division problem instantly becomes a multiplication problem, in which this is valid. Okay.
Quiz 3, question 2. It's with the region model.
Oh, so thankfully I didn't see anyone choosing completely different shapes. So this is the problem where he gave you like 1/4 plus 2/4, right? Use the region model to illustrate this. So all I really needed was represent 1/4. So yeah, do 3 cuts, so I can do 1/4. Represent 2/4. Right, so then you add these together, you get
Oh, okay.
3/4, right? Yeah, that's all I needed to see was, I want you to set up the region model for both and then just put them together. Alex, I'm sorry, go ahead.
Did you look at 6.3 for A number 40?
Let's see, 7. Oh, yeah, okay. This is the one about the guy and his son, and they're so far apart. So real quick story, a friend of mine said to me, Jeff, you know math, why, if I'm twice as old as somebody now, why am I not still twice as old as them 10 years later? You guys all with me? Does it make sense you're not gonna still be twice as old as them 10 years later? Because one is addition, the other is multiplying, so they're not gonna quite work together? Yeah, thank God. That doesn't hold, because otherwise we'd all be aging much faster. So this one, the only thing it has in common with what I just said is it's got to do with age. 7 years ago, my son was 1/3 my age at that time. 7 years from now, he will be 1/2 my age at that time. How old is my son? And you're all like, listen, dude, if you don't know how old your son is, stop trying to get help from us, all right? But you're in trouble. There's trouble going on there. Did anyone try this problem? Does this look familiar?
Yeah, we did something like this.
Huh?
We're talking about,
We talked about this specific one?
Yes.
No, but one similar to it.
Yeah, there was one similar to it. We didn't talk about this specific one.
It was like something in a grandson and a
No, there's the one about cutting up the estate, I think, right?
No, we never had this.
Okay, I'm sorry. Alright, obviously it had a big impact. Changed my life.
It's easy for you when we're over here, like, just like crying over.
No, I'm sorry. Well, I mean, yeah. So, anybody try this problem, number 40? Or did y'all kind of like not do it, hoping I wouldn't notice?
Wait, which chapter is this one from?
6, 2, 5, 6, 3. Any ideas on if you're playing the home game there? Any ideas on what I can do with this crazy ass problem? You could guess and check. Yes? Again, there's another situation where we learn some stuff and that's not just living in its own little place, it's everywhere, it could always be true. Me, what do you think I would do?
You can find some measurement way.
What's the basic thing I would do? What do you think I would do? I'm all about the algebra. All about the
Set them equal to each other.
No.
7 minus.
Calculator. Huh? I would use a variable. I would use a variable. But I don't, so nobody try this problem? All right, I'm not going to say a word then. I want you guys to try it out. I'm not going to say anything. I'll say that much. I would use a variable. Are there other ways to do it? Hell yeah. Yes?
And minus a third or something?
So the question is, how old is his son currently, correct? All right. So let me help you out a little bit. So in algebra, we let the variable equal the thing I want to know, if we can, if it makes sense. Yes? Okay. Hold on to it. Don't say it, because I want everybody to figure it out. Be quiet. So if X is the age of the sun now. Snow. Good job. We also have the age of the father here, right? Bless you. You with me? So 7 years ago, my son was 1/3 my age. So if Y is the age of the father, 7 years ago, how old was the father?
30.
How do you know he's 30? What?
I would just assume it was 30. Because a 10-year-old boy, 1/3.
Yeah, the other way to do this problem is to guess and check. And why not? You could do that. It's fine. Right? How old is the father now? Y. So 7 years ago, how old was he? Y minus 7. Okay, so 7 years ago, my son, so X minus 7 equals 1/3 Y minus 7. He was 1/3 my age at that time. So 7 years ago, the son's age was 1/3 the father's age. 7 years from now, I don't know why I'm doing all this. You might not want to do it this way, correct? I don't know. I'm just weird. 7 years from now, he will be 1/2 my age at that time. So what do I write over here?
Equals 1/2 times y plus.
Yep. Now, if you do it this way, you have to understand how to solve when you have more than one variable, right?
This is way beyond our.
This is way beyond anything we've talked about. This is using a variable, but this is like systems of equations kind of stuff. Yeah. Now, what's another way you could do this? The way you already started, right? Obviously, the father's not going to be 6 now, so you can pick a number that kind of makes sense. Also, think about the 1/3. In order for that to make sense, 7 years ago should be a multiple of 3. Does that make sense? Because I'm pretty sure the problem's not going to say the father is 42.793 years old. It's going to say 42, correct? Do you understand? So you want to pick a number so that when I subtract 7 from it, it's divisible by 3. Now think about ahead. You want to come up with this. So you want this number. This number, so that when I subtract 7, is divisible by 3. And when I add 7, it's divisible by 2. That's another way to do this problem. You guys kind of with me? Huh? The number, let me see if you guys are cool with this. The number cannot currently be a multiple of 3 or 2. Because 7 is not a multiple of 3 or 2. Do you understand? If I have a multiple of 3 right now, give me a multiple of 3. No. How much do you have to add or subtract from it so it stays a multiple of 3? 3, right? If I add or subtract, so give me a bigger multiple of 3. Big.
33.
33. Beautiful. If I subtract 7, is that still a multiple of 3? Of course it isn't. So I'm trying to use, in order to escape Jeff's weird-ass way of doing shit. Yes? And I will agree, this is weird, but this is the way I think. In order to escape that, let me use the information they gave me to my advantage. I know the answer is going to be a whole number. I just know it. It is. It just is. So I know whatever number the sun is currently, if I take 7 away from it, it has to be divisible by 3. This is about the 5. I think you're trying to see what I'm trying to say. It's not the way I would immediately think to do it, but that's another way you could do it.
The dad's dead.
Huh?
The dad's dead. That's the answer. There you go. Yeah, there you go.
The question about how old is the sun? That's funny. How old is my son? You're dead. How old is my son? Ooh.
Can we find the reciprocal of 8 and 1/10?
Can you? Guys, real quick, guys. Write this fraction down. Sorry, Ramondo, this has got to do with that problem, just a different problem. 11 over 15. What's the reciprocal of that?
15 over 11.
Any frickin' fraction I give you, that is already just a single fraction, not a mixed number, right? Write this fraction down. 819 over 11. What's the reciprocal?
11 over 819.
Beautiful. So, why is the question hard the way I gave it to you? 8 and 1/10, find the reciprocal. That sucks desperately because it's not written as a single fraction. Can you make that into a single fraction? 8 and 1/10.
Just make it an improper.
Improper, and then you flip the sucker.
So 10 goes into 8 and then add the 1.
10 times 8 plus 1, yeah.
Got it.
Yep. Now again, I'm sorry, I don't want to make it sound like, yeah, because maybe you're thinking maybe there's a way I can do mixed numbers. Not really. I need to make it a pure fraction, then I can flip it.
Cool.
Yes?
Can you do, number 11 on the practice test, part?
Oh, that's kind of like what we were talking about earlier. Guys, if I ask you to divide two fractions, what's the first step?
That's actually the hardest one. I got 2 different answers for 2 different ones.
So, again, if I ask you to divide two fractions,
Change it. That's all.
is that the one? Yeah. What's the first step?
Flip it.
Flip what?
Right side.
This guy.
Change it. Flip.
Flip it, change it, and then
Flop it.
Lock it.
Now, what happens here?
now you multiply across.
Yeah. And does anything cancel? Does anything reduce? Yeah. See,
Why would
so
they
you always
cancel?
look for that first.
Why does that cancel?
Say again?
Why does that cancel?
Because they're both divisible by
3.
3. 1 plus 5 is 6, 2 plus 4 is 6, they're both divisible by 3. Why doesn't 6 go into both?
Because 3
Because it's
not.
not even.
Not even. So 3 goes into that, 3 goes into that.
4 times
Yep, and now you just multiply across. Now you're guaranteed the answer you get won't reduce because its parts won't reduce.
And
Exactly.
if we didn't do that first, we could reduce at the end.
You could, but then you run the risk of it being really big
Right.
and making mistakes, yeah.
Just trying to put all these pieces
Yeah.
together.
Tell us, do an example of the lower third of
Oh yeah, like number 2.
Three, number, yes.
So, here's the trick with LCM. What's the LCM of 9 and 3? GCF of 9 and 3 is 3. What's the LCM? So, GCF, greatest, biggest chunk, greatest common factor. What's the biggest number that's in both of them? LCM, least common multiple. What's the smallest number they can both multiply up to be? 9. Good. What's in 9? Is 9 in 9? Is 3 in 9? Yes. So the LCM is the smallest number that has both numbers in it. What does that mean, Jeff? I don't know. So if I want to find the LCM of, I don't know, 50 and
122.
no,
Like 90?
let me think for a second. Old man thinking. And 144, sure. That's gross. I mean, let's just make it 50 and 42, sure. Okay. Can you break 50 down?
25 and 2.
25 times 2, keep going.
5 times 5.
5 times 5 times 2. Break 42 down.
6 times 7.
Keep going.
3 times 2.
That
So-
would also be a terminator.
Huh?
Sorry.
Oh yeah, look at you go. So that was the bottom of a fraction. You could get a terminating decimal point. Chickens the ass in. The LCM, it's not the best example I've ever done, but the LCM has to have both numbers in it. You guys know, you guys understand that. You just don't think about it that way. What's the LCM of 6 and 4? No.
12.
That is a common multiple, but it's not the lowest. 12. Why is 12? Does 12 have 6 in it?
Yes.
Does 12 have 4 in it?
And it's the lowest
Yes.
one.
And it's the lowest one that has both of them in it. So the LCM has to have 50 in it. It's got to have 5 times 5 times 2. It must have 50 in it. So start there. Write one of the numbers down. It's got to have that whole damn number in it. It's also got to have the whole other damn number in it. So it's got to have a 3. Do I have a 3 yet? Give it a 3. It's got to have a 2. Do I have a 2 yet? Yeah, so screw the 2. I need a 7. Do I have a 7 yet? No. There's the LCM. Does it have 5 times 5 times 2 in it? Does it have 3 times 2 times 7 in it? Yep. Let's do 6 and 4, what we just did. 6 and 4. 6 is 2 times 3. 4 is 2 times 2. Yes? Yes? Yes?
So you just need 2 2s and a 3.
LCM. I need a 2 times 3.
And then
No. I also need 2 2s. Do I have 2 2s? So I need to find a 2 times 3. I've got a 2 times 3. I need to find a 2 times 2. Can I find that here? What am I missing to find 2 times 2?
Like 2.
1 more 2. That's why the LCM is 12.
And why didn't you add the other 2 for the 50 and the 42? You only have a 1 times 2.
You have both
Because
items
there's
left.
1, 2.
Because I already have a 2 when I write this. So I already have a 2. I don't have to, it's not, so, but how many 5s do I need?
If you have a double, you
Do
can kind
not
of start
do
with the
the
doubles and then.
I have to find 50. What makes 50? 5 times 5 times 2. So I need 5 times 5 times 2. If I didn't put both 5s, does any of this make 50?
Oh, but if you cover the other 2s, that still makes 42, right?
Yeah, there's 5 times 5, there's 50, and there's 42. You can find both numbers in it. Here's a really cool thing. You ready? 6 and 4, when I asked for that, I heard somebody say 24. I don't blame you for that. What's the GCF of 6 and 4? 2. So to find the LCM, I could just multiply them together and divide by the GCF. 6 times 4 is 24, divided by 2 is 12. I can always do that shit. I can always do that. Always. So what if I had to, add 1/15 plus 1/9? What is the GCF of 15 and 9? 3. So then I can do 9 times 15 divided by 3.
Why wouldn't you divide 15 by 3?
Because we've only got one 3. When it dies, it's dead.
Well, then could I, like, do like the 9 times, say, 3 divided by 15, so like 9 times 5?
Yeah, I could have done this instead. 9 times 5 is still 45. No? Again, that's just an alternate way. You don't have to do it that way. That's the way I do it, to be honest. I just multiply them together and then divide by the GCF. That's the LCM. So, why does this answer, that's not a good example. The 50 and the 42. That's not the best either, but oh well, too bad for me. Somebody was like, why don't you have 2 2s in it? And of course I don't need 2 2s in it because I can find everything I need, correct? What is the GCF of these two? What's the GCF? What's the biggest number they have in common? This doesn't have a 7. 2. So if I just multiply them all out and then divide by 2, I get the LCM. I don't need 2 2s because each one only has 1 2.
So is the lowest common, like, is it just the 2 times 3 times 2, not the multiply that?
No, I mean, you do want to give me what that number is, sure, but yeah. It's kind of like if I say, what do you have to eat, and you list the ingredients of cake, and I'm like, just say you have cake. So this is the ingredients of 12, and then so you can just say 12. Yeah. Yes.
So, knowing this, how would one go about solving number 2 in practice? Is that just a list of factors and you would just multiply all of them?
Yeah. Okay. Okay. You ready? Here we go. Here's the ultimate good shit. If I've given it to you already factored, right? Like number 2. Let's just go ahead and do that one.
Mr. Wallow, while you write that, would it be allowed to complete that, like, freaking actually do 3 to the 4th times 5 to the 5th times 11 to the 2nd, and then go from there?
That would be
It'd be long though, right?
insane. I have this big ass number just staring at me.
Yeah.
So what's the first step we do when we're trying to figure out these things? We factor that. So this is already factored, so most of the work's already been done for me. So don't undo that work. Now watch, I need you to understand this. The LCM, let's start with GCF. The GCF has got to be the biggest number that both have. Let's start with the obvious thing. Do they both have a 17?
No.
Will 17 be a part of this answer? No, screw the 17. Do they both have 4 3s? So the answer can't have 4 3s. How many 3s can the answer have?
2.
So do you start to see a shortcut when it's written like this? What's the lowest power on each piece? How many 3s do they share? Do they have in common? 2. What's the lowest power on the 5? 5. What's the lowest power on the 11? 2. What's the lowest power on the 17? 0.
Oh, fuck, okay.
LCM is the opposite. LCM says, give me the biggest frickin' thing they both have. So the answer's got to have 4 3s in it. That means it has 2 already. It's got to have 6 5s in it. That means it's already got 5 of them in there. Yes. It's got to have how many 11s? 5. And how many 17s? 1. So whatever the shit that number is. Now, if I give you this kind of problem to test, you don't have to multiply that shit out. I don't want to see the big ass number. You can show me the DNA. Yeah.
All right.
You
Do
can.
it just for you.
To make you go down and see if they got it right.
Nobody ever does anything for me. Is that alright?
Well, we don't include the 17 on the GCF.
Because GCF is the biggest thing they both have. Do they both have a 17? Good. Do they, and again, so that's why the shortcut works. You take the smallest power for GCF. Because they don't both have 6 5s, correct? Do they both have 6 5s? Do they both have 6 5s? Does one of them have 6 5s? Do they both have 6 5s? Do they both have 5 5s?
Yeah.
Yes, so they both have 5 5s. That's part of the GCF, because that's the biggest amount of 5s they both have. So what's the shortcut? Smallest powers for GCF, biggest powers for LCM. It's almost too crazy to believe. Yes?
Do you remember the homework again? 7.2, part B on the third line.
I think I'm there, this one.
Yeah.
Yeah, so the total value of any sum of money that earns interest at 9% per year doubles about every 8 years. What amount of money invested now at 9% per year will accumulate to about 100,000 in about 4 years? Blah, 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 blah. Okay. The first thing I want you to notice, all right, don't worry about the numbers. Notice this. If something doubles every 8 years, in 16 years, how many times will it double? Twice. You with me? So if I had an account that doubled every 8 years, and I put $100 in there, after 8 years, there's now $200. After another 8 years, so after a total of 16 years, there's now twice that. There's 4 times as much, correct? So if I'm talking about 40 years total, how many doublings should happen? 5 doublings. You guys with me? Does that make sense? So that's the very first thing I would notice about this problem is, talking about a certain amount of time for doubling, then it can be a total amount of time. Well, how many doublings are going to happen, right? So this one's backwards. It says, how do I end up with 120,000? So how many doublings do I have to undo now? How many doublings occurred, like we just said, to get to 120,000? 5 doublings. So how do I work backwards?
Take away 5 doublings.
Yeah, undouble it 5 times. Divided by 2 5 times. Does that make sense? I did the whole problem. I'm sorry. I meant to stop somewhere. I always get so excited about an idea. This idea is kind of cool. Have you ever heard of Half-Life and stuff like that? Not the video game, but there's like Chernobyl. What's up with Chernobyl? Is it good to go there?
Oh,
No, it's monsters. No, it's irradiated, right? So there's a
Elephant's
half-life. The half-life of the radiation there. So it's the amount of time it takes for half of the radioactive material to still be radioactive. So I think the half-life is like 5,700 years or something. So in 5,700 years, it'll be half the level of radiation there was at the time of the explosion. Anyway, sorry.
What's the math? Come
Huh?
on. Math.
So this is
Solve it.
this is thermonuclear.
Sure.
Can we
Do you want to play a game? Yeah.
7, 1, 2, 5, test 3?
7, what?
Sorry, I meant test 3. I looked at math 1, 2, 5 when I went to
Oh, okay, okay. Okay. So let me give you a similar problem. And ask you why this problem is easier. So if I gave you this problem and said, can you find values of x that would make this true? Right? What values of x would make that true?
11 through 19.
So don't look at that problem. I'm going to work towards it. Sorry, Ramon. What would work? Right? 11 would work, yes. What else? 12 up to 19. Why was this problem easier than that problem? What's the main difference? What's different about that problem?
The denominator.
The denominator. So yeah. So first thing I want to do,
Is find out.
make the denominators the same.
Right.
So the ones that are 7s, make them 20. So this is not the do a simpler problem, but it's kind of like, what would have made this problem easier, and then how can I make the one I got to work with look like that? If only the jackass Jeff would have made these bottoms the same. And I'm like, oh, cool, I can do that. I can make the bottoms the same, right? Does it make sense?
Whatever you do at the bottom, you have to do.
Totally.
So now,
Chickens, yes. Okay. Shake it. Yes.
The divisible rule of 9, can you just tell me real quick?
Yeah, somebody help me out. What's the divisibility rule for 9?
Is it multiple of 9?
Mhm.
Okay. But
So if you add up all the digits in any given number, if they're a multiple of 9, 18, 27, the whole number is divisible by 9.
What went on the top though? I guess that's where I got lost.
What's up, sorry?
Find the whole number x.
Yeah, so you got 3 7s, and you get x over 21, you have 4 7s, right?
Yes.
What does this become? What over 21?
Becomes a 9 over 21.
What does this become?
A 12 over 21.
And now it's just a problem exactly like that, yes? What numbers would make this between 9 and 12?
10 or 11.
10 and 11, yeah.
So that's the answer. It's gonna be 10.
10 or 11, yeah.
Oh shit.
Just like this one had 11, 12, 13, 19, yeah.
Can it be 10 like comma 11 or does it have to be or 11?
Comma's fine, yeah.
16 and 19B on the practice set.
Oh, 16. Sounds like you made somebody's day, let's see. Oh, 16B?
Yeah.
Okay. Use compensation,
I just
okay.
forgot what that-
What was compensation again?
Take another number from another number to make it.
Yeah, so in this case, this is about multiplication, so I want to take a factor away. So 4.5, poor little dude sucks. But what would make it become a whole number? If I just doubled it, yeah? So can't I steal a factor 2 away from 60? Isn't this 30 times 2 times 4.5? And what's twice 4.5? What's twice 4.5? What's twice 4?
8.
What's twice a half?
9.
So 9, yeah. And 30 times 9 has to be easy.
Yep.
Okay. Compensation means you take from one and give to the other one. You gotta be careful about the operation though. I can't take 2 away and make this 58, because that would be additive. This is about multiplication, right?
Wait, you compensated by cutting the 60 in half, and is that why you doubled the 4.5?
Yeah, totally. So I took a 2, I broke this down, and now I can use that 2 with this, make it a nice whole number, and then I can make that. Then it's easy to do. So
This shit you gotta think of.
as a math teacher, and there are people that make a living out of being like these human calculators. I don't want to do that shit. But I have picked up a ton of little things like this. This is one little thing I do. And students are like saying, how did you get that number so fast? Because I know how to manipulate the damn things. And this
How
is
did you
one
learn
little
that?
thing. Huh?
How did you learn that? Just over time?
Over time. Somebody might have told me. I can't remember. But yeah, who
He's
knows?
also a mathematician.
Got somebody a hand up. Okay. Oh yeah, you had another thing. What was it?
19B.
19B. Yeah, that one's grosser than I meant it to be, I think, but
That's the,
you can stop with the fraction for that one. How do you rewrite 563.4 as a fraction? What was it? 5634 over what place is this in?
2/5.
Huh?
2/5.
What?
Oh, I see what you're doing. Be careful. I want the whole thing as a fraction. So I put all the digits. 5634. What place is this in? Tenths. 833. What place is this in? Hundredths. Really quick. What would you estimate 833 divided by 100? It's about 8. Yes? And what's 5,000 divided by 10? 500. Yes? You guys at all with, I mean, that part was just a little extra to show you. I don't know if you're having trouble with. The way I write the fraction is completely dependent on where the last number is. So here the last number is in the 10th spot, so this is going to become some tenths. The last number here is in the 100th spot, so it's going to become some hundredths. Okay, yes?
I am, you done with that problem?
No.
Okay, sorry.
How do I divide fractions?
Keep it, flip it.
Pop it, twist it, turn it.
Hold it.
What's this figure of speech? It's key,
Keep
Somebody
it.
else.
Change
Keep
it.
it,
Change it.
change it, flip it.
that's the one. Your word, your word.
Kentucky
Almost.
Oh,
If you did keep it, flip it, change it, then it'd be Kentucky Fried Chicken. Kentucky Chicken Fried.
baby, baba.
And now I can reduce these, yes? When I made this problem, I was not very careful at all. Nothing really happens here. Poor little dude, so you can just keep it like that. Normally I would give you one where more stuff cancels. Huh?
Are they reducing?
I don't think so.
Well, like, I don't know, so I got my answer to be 67 holes and 76 over 125.
125?
I don't know.
That kinda tells me that you multiplied these or something.
I did too, I did,
But this is division, you gotta first flip that.
I did.
How do you get
I
120?
know how mine works, so I'll show you after class.
Okay,
I
okay.
promise. I had it.
What question was that?
This-
Oh,
This was 19B.
19B, yeah. The main thing I'm looking for on that problem was, are you able to go from a decimal to a fraction? And then are you able to do some fraction stuff to that?
And if we do 15, estimate,
Yeah,
like,
well, okay. So, the way to estimate something is to go, man, I wish these numbers were this and this, cause it's easy to divide. So what's close to 17 and what's close to
well, I mean 7.6.
17.6 and 6.3 that would go into each other? 18 and 6, yeah. Now, if you say 17, what was it, 17.6, blah, 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 yeah, 6, divided by 6.367. If you say this is approximately 18, that went up, correct? Over 6, that went down, correct? And you get 3. That is a good answer. You can stop there, but I want you to realize something, and I think I wrote this on the key.
So we just do a wiggly line and say, hey, that's where I'm at.
That's approximately. That I asked you to estimate. That's why you're allowed to do that. If I say simplify, don't do that shit. I want to know the answer. If I say estimate, you're allowed to make the numbers round. You're allowed to make them whole. You're allowed. Of course, you're just trying to get a rough estimate. Can somebody tell me if that's a high or a low estimate?
And then hi.
It'd be like a mid-X.
It's high. Nope, it's high.
Oh.
If I make the top of a fraction bigger, isn't the answer bigger? If I make the bottom smaller, I'm dividing by less, isn't the answer bigger? So I did both of those things, so the answer's bigger. Can somebody take a minute? What is 17.6 divided by 6.367? And no, I won't do that in my head. Leave me alone. 17.6 divided by 6.367.
2.764253.
2.76, blah, 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 okay. Which is definitely lower than 3. So 3 is a high estimate, but it's still reasonable because I didn't change it by that much. So when I ask you to estimate, you think make the numbers round, you think make the numbers work with each other, but you think don't change them like that much. So I don't want to make 17 become 30.
How do you feel like, how do you know when it's like too far off, like when your estimation's too crazy? Like what's the cusp, what's the line?
Well, two things. If I change 17 by a lot, I have to change 6 by a lot
Right.
to keep them kind of like going the same direction. So for example, if I made 17.6 become 24,
Right.
and it makes 6.367 become 8, I still
Yeah.
get 3, but that's kind of weird. So I try to keep them within like one, like 17 can become 18 or 16, and that's sort of acceptable. And 6 can become 7 or 8, 7 or 5, and that's sort of acceptable. Or 6, yeah. Somewhere in that range. Does that make sense? Yeah. There's a whole lot more to the estimation picture, by the way, Armando. We're not gonna get into the whole thing, yeah.
For the range estimate, do you do the low and the high?
Yes.
So it's like
So remember when you're adding stuff, well, for this one, they're all relatively the same order. They're all like single digit decimal, like 6 point, blah, blah, they're all single digit with decimal part. So the low estimate, what would I make it become? 6 plus 6 plus 9, good. And the high, you just take them up, yeah. So if I would have had, if the middle one was just 21 cents, the low estimate would have been 6 plus 0 plus 9. I would have pushed it down to the nearest dollar. Yeah.
What do you think of it, like, the first one? For the first decimal, for the tenth place,
Sure,
what would that be point five?
no, but you want it to be very easy to do in your head, right? Yes.
How would you do, for 16A, how would you use distributivity?
Distributivity.
Thank you.
Isn't that more when there's like multiple?
You can ask the question too, it's okay.
There's more.
So here's the cool thing about this. What's 60 times 0.5? Why is that easy? Because what's 0.5? A half. So what's half of 60? 30. And what's 60 times 4?
120. 240.
240. So then what's 60 times 4 plus 0.5? Distributivity.
Oh, okay.
Yeah. So if you break the 4.5 up into a mixed number, 4 plus 0.5, distributing 60 each piece is easy. 60 times 4 is easy, 60 times a half is easy. Do you see that? That's how to use distributivity with a fraction. I actually kind of think of it as a mixed number then. Does that make sense? Not a fraction, but it does make sense. Yeah.
When it says different primes for number one,
Oh. Yes. Yeah, so they're, so don't mean they can't both be 3, for example. Because then the answer would be different than what I want. So P and Q are different primes, so like 3 and 5, any 2 primes.
okay.
How do I figure out how many factors they're gonna have? We all know this, we know how to do this. So for example, if I had a number and I broke it down and I got 2 squared times 3, how many factors will it have? You guys know how to do this. 3 times 2. Increase it by 1 and multiply, yes? We talked about that?
Yeah.
Before. So there should be 6 factors in 12. Right? 2 squared times 3 is 12. What's the powers here?
We don't know.
Yes, we do. I have 1 of each. So it'll be 2 times 2, 4.
Oh,
Do you remember this? So, how do I tell how many factors 60 has? I break it down. 10 times 6, 2 times 5 times 2 times 3. So it's 2 squared times 3 times 5. So how many factors does it have? 3 times 2 times 2. I increase each power by 1. I showed you why that was true, and I just gotta remember how to do that. So in 60, there should be a total of 12 factors. And sure enough, if you do it, it'd be 1, 2, 3, 4, 5, 6, no 7, no 8, no 9, 10. So it's 1, 2, 3, 4, 5, 6, and there's gonna be another 6, so it's gonna be 12 total.
I'm on the practice test number 5. What is like the actual way to do it besides just letting your eyes relax till it?
What's the thing about, be careful about number 5, real quick?
Well, they're not even parts.
Yes. So the very first thing you should do is split that top white part into 2. Don't count that as 1. That's the whole idea, is they have to be the same relative area to be able to be counted as
Yeah, if
a
you turn your
piece.
page to the side, it's like, it's already in half. And you just put it in.
Yeah, the top piece, you have to draw a line down the middle.
But you can turn it, and then you can see the 4.
Okay, whatever way you gotta look, yeah, you gotta make sure that you count that as 2, right?
Mhm.
So yeah, it's just 3 out of 8, yes.
I've been watching Planet of the Apes a lot.
Oh. Get your hands off me.
You've
Yes.
been gone.
Yes.
did we ever go over scientific notation? Because I'm pretty sure that's where we like.
Yeah, I don't think we ever did go over scientific.
That should just not be on the test.
It's like, it's not hard.
I think we might have done it.
So very
It's
quick,
like 10 to the 7.
Yeah.
And you just count zeros.
very quick,
I need to watch those.
very quick, guys. I'll let you pass this. So, if I wanted, does everybody agree with me that 4,000 is 4 times 1,000?
Yeah.
That's scrounge. What is 1,000? How many tens?
3.
3.
There you go.
That's scientific notation. So, the shortcut is, and young Jeff was bad with left and right. I always got them mixed up. To be really honest, present day Jeff still has to do like this sometimes when he's driving. Turn left. Okay. Because this makes an L, and this doesn't, so that must be left. Okay. I'm fine with that. I got all kinds of shit in my head, so. Oh well.
Just make
If
it
it
work
works,
right,
it
you're
works.
fine.
Yeah. Real quick, I'll do this one. What is this as a fraction?
As a fraction.
Yep.
4 over.
1, 2, 3, 1,000. Isn't that 4 over 10 to the third? And isn't a negative power mean flip? So watch this. Watch what I can do. A positive power just means move the decimal that many times over to make the number bigger. Because I'm actually multiplying by 10 3 times. So if I had 7.1 times 10 to the 9th, I'm going to move the decimal 9 times that way. Because I'm multiplied by 10, 9 times. So I'm going to move it once, 2, 3, 4, 5, 6, 7, 8, 9.
No.
What? You guys with me? I got to move the decimal
Because if you have 1/3 as a fraction, then.
1/3. What do you mean? Sorry.
But I'm just saying, like, if you were to have 1/3 as a fraction and you were to multiply 1 times 3, it's 3. So what?
What?
So
I'm so lost.
there's nothing about fractions here.
You have the 4 over 10.
I do, just to show you that if I see a negative power, that means to go backwards. So if I had 6.23 times 10 to the negative 5th, I'm going to move the decimal 1, 2, 3, 4, 5 places
Okay,
back.
to the negative.
So the neat thing is I have 1 less 0 than the number was. That is all scientific notation is. If it's, I'm sorry?
No, I just didn't see the negative, so. I was-
Okay, gotcha. So if the power is negative, I want to move it back that many times. If the power is positive, I'm going to move it forward that many times. I always hated left and right. It makes so much more sense. If I multiply by 10 over and over, I get bigger. So I'm going to make it bigger. If I divide by 10 over and over, I make it smaller. So if it's a negative power, I'm going to make it smaller by that much. Are you guys somewhere? You guys with me? Okay.
Meaning like you move the decimal
Totally.
this way.
Yes. Okay. So how would you write this in scientific notation? How many times do you have to move the decimal until there's 1 digit in front of the decimal? Yeah. 1, 2, 3, 4, 5, 6. So 5 times 10 to the negative 6 because it started small. Did I not put any on here?
You gave us one.
Maybe like a couple more for now.
Where's the one I gave you? Oh, there it is. Yeah, look at me. Obviously, it means a lot to me. All right. It's just an application of decimals and exponents. So, of course, math people will get all excited when there's more than one idea in something. I can't remember. I think the homework is a little more interesting. Let me show you an application of this. Okay, watch this. If I had to multiply this, 12. I'm not sure where I'm going to end. Sure. Times. Okay. So you have to do this by hand. Do you want to do this and then put that underneath? So watch what I can do. Write this as a scientific notation number. I want to move the decimal until it's between, so it's got 1 digit in front of it. Here's a really weird way I look at this. I'm going to suck all the 10s out of it. I'm like the weird ass vampire. I want to suck all the 10s. So if I stop here, did I suck all the 10s out of it? No, 12's got a 10 in it. So I want to stop, bam, right when there's 1 digit in front of it. How many times do I have to move the decimal to do that? 3, 6, 9, 10. So this is times 10 to the 10th because it was a big ass number. So it's a positive power. What's this one become? Yeah.
Oh, because it's
Why
obviously
did you
less
get
than.
the two?
Sorry?
Where'd the two?
Because there's a 2 there.
Oh.
So it's 1, 2, 3, 4, 5, 6, 2.0. So 2 times 10 to the negative 6.
So you always move, not the numbers, but the entire number of numbers, not the zeros, I'm sorry.
You're moving the decimal,
Decimal,
which means if I move the decimal, I don't need all these zeros anymore.
copy.
And if I move the decimal, I don't need all those zeros anymore. So it becomes much more compact and easier. So when astronomers are talking about how far away stars are, they don't want to write 87,000,000,000,000. Screw that shit. I'm going to say, what we really say is, we say on the order of 10 to the 10th kilometers away or something. It almost doesn't matter what this number is, because we're talking about 10 to the 10th. Holy shit. Now, how do I do the next step? You ready? What's 2 times 1.23?
2.23, whoa.
Double, 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 right?
Yeah.
And what's 10 to the 10th times 10 to the negative 6? What do we do with the powers? 10 4, good buddy.
Nice. So simple.
It's a lot easier when just trying to do the whole damn thing. Yeah. Okay. Maybe? 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 So obviously I'm probably not gonna have that many problems in there, but I'm gonna have a very basic problem. That was a more interesting application of scientific notation. So chemistry, you're talking about very small wavelengths of light and so forth, or very tiny orders of magnitude of looking at the paramecium or whatever. So you don't want to put 0.0000000. No, screw that shit. You're going to say 7 times 10 to the negative 11 meters or whatever, right? Yes?
3 on the test, practice test.
Oh, you want an inch for the test? Yeah.
Yes.
Good try.
I just drop the answer to the test, no context.
Yeah, 3 is a good one. I like 3. I would like 3. Oh, you're all just dead. Oh, you're not dead.
Good.
3, if 5 over x is less than 9 over y. So real quick, guys, if I give you 2 numbers, 2 fractions, and I say determine the right sign to put in the middle, what did you do? What would you do? You're not allowed to divide them, right? You do cross multiply, sort of, right? So again, we're not really cross multiplying, we're doing a little trick. 18 times 11 is 198. 14 times 13 is 182. Don't hold me to that.
Yes.
You're being held.
Neither.
Good job.
So which way should the inequality go?
Point to the table number.
What's bigger?
198 is greater
Yeah, so
than
that should be go that way.
Point to the table number.
So 18 times 11 is bigger than 14 times 13. So look, 5y is smaller than 9x. Does everybody agree with me? Just multiply it up and I know exactly, but the relationship holds, right?
Yeah.
Okay.
Sick.
Now watch, we're obviously not done yet. Because my question is 9x minus 5y a positive number? I could do one thing and get 9x minus 5y to show up. What would I do to make it show up? How do I get 9x minus 5y? What do I have to do to both sides?
Cancel them out.
So I gotta subtract 5y, yes? Jeff, there's a 5y. 0 less than 9x minus 5y. What does it mean for a number to be positive? It's gotta be bigger than 0. What does this say? Read it this way.
5y minus
9x minus 5y
It's greater than
is
0.
greater than 0. Or 0 is smaller than that, so is that positive?
Yeah.
Yep, cool.
You have to show.
Now, that would be the work you show.
Of course.
That's the work, huh? Sorry?
I just put yes because I'm.
Oh, okay. That's a 50-50 shot, so I can't give you
Some points though for that.
points for that. Well, at least you didn't leave it blank. But
At least.
Yeah, at least a 10.
Anything's better than nothing.
that's true.
That is very true.
Sorry?
Are you turning this up?
Never. Don't give me that. I got the answer key for it, so I don't
Okay, then, quick question, I just wanna check my answer on number 10, is it 432,000?
Oh,
That sounds familiar, yes.
Work for that one?
yeah, that was my next
So
question.
here, let me give you guys the answer key.
Okay, and then another question.
You're gonna-
Well, here's the answer.
Yeah, yeah, I know.
Thank you.
Let me see what it is.
You guys, make sure I got these right. Oh, yeah, oof. Wow. I'm so tired.
That one. Oh, I never closed that. That's fine.
That's right, okay. Okay, it's not too bad. So just to remind you guys, I'm averaging about a 97 on my answer keys. I'm not one of those math teachers, you guys know this by now, that says I don't make mistakes. I make all kinds of mistakes. Are you kidding? I feel pretty good about this one, but let me know if something seems like it might be out of place. Yeah.
I'm a little confused on 17. Why did you go to 4.5 times 10? 'Cause I did the 45 times 10.
Oh, like I just said, suck all the tens out. 45,
Oh,
45 still has a 10. You gotta move the decimal until there's one digit in front of it.
Okay.
So it should be 0 through 9 point something times 10 to the something.
Yeah.
Yeah. Because the whole idea, that's the whole idea of scientific notation. That's why I don't care that I sound weird when I say suck the tens out. I don't give a shit. Scientific notation, that's his job. Take all the tens out of something and put them by themselves. That's its job.
And then how come you didn't simplify 2011?
Where's it at?
Number 11?
Oh, you mean make it into a mixed number?
Yeah.
You can do that if you want to. If I don't say I need it in a certain form, you can either leave it.
Simplifying what in that?
No, simplify would mean reduce, and I can't reduce that. If you want a mixed number, you can do that. That's fine. In general, and I'm not going to hold to this, but in general, if I start with mixed numbers, end with mixed numbers. If I start with improper fractions, end with improper fractions. That's a generally good rule. Unless I say something else as an instruction. Yeah. Yeah.
Did somebody ask about number 10, sorry?
Number 10? Sort of, but not really. Somebody checked their number, their work.
Then somebody beat me at it.
So I used the variable. Again, algebra guy. What do you want from me? Did somebody do number 10 a different way? It would be really hard, I would think, to do it a different way. Guess and check would suck so bad.
We could draw a picture.
No way in hell. Huh?
We could draw a picture.
I did one
Do you like his name? Come on.
Oh.
Mr. Last name.
Mr. Last Name. I was feeling so creative.
I've heard of it.
Mr. Last Name. Oh God,
Or
whatever.
Mr. Last name.
Huh?
R.I.P. Mr. Last Name. He will
Yes,
be missed.
exactly.
1/2 of his estate to his wife? Whoa.
Look at his other family.
Yeah, poor sucker, man. Be like that.
Oh, wait, you didn't even less than your wife?
Why would I leave her? She-
His estate was a double wide trailer, so she got half of that.
She was single.
Y'all are,
Oh, wait, which half?
you all are imagining
The left half or the right
the
half?
half she really didn't like. So
Or like the
I
front
don't
and
know.
back?
I'm not.
Dude, he
Mr.
just saw
Last
it
Name.
straight in half like this. There's
Pretty much.
4 of them.
Pretty much.
That wife got a rocker.
Mr.
In the afterlife, seance.
Yeah.
And Ghostbusters will be there.
A Ouija board? A Ouija board? Give him a shit.
Yeah, the Ouija board. Huh?
Can I ask like what your thought? Can you just go through the process of thinking,
So,
oh, this is should have her.
what is the thing I don't know?
Everything.
No, there's one thing I don't know.
Value.
Value of his estate. So in algebra, if there's something I don't know, I call it X. How much of the X did I give to my wife? Let's say I am Mr. Last Name. I am deceased, and yet I am talking to you. I gave her 1/2 of that. So I gave her half of an X. Now the thing to be careful about, I gave 1/9 to each of my 3 children.
So you need 3/9.
3/9 X to the kids. And then I gave where is it at? Sorry, I missed it.
4.
1/9, 1/24 to each of his 3 grandchildren. So I gave 3/24 of the estate, which is X. Are you with me? That's the power of algebra. I know you guys might not agree with me, but algebra says if I just knew what the freaking number was, I can do shit to it. So algebra says, okay, the next best thing is, let's call it X. So then we can do shit to that. So if whatever X is, whatever that number is, half of it went to the wife. So half of X. And if I add all the parts up, that should equal X at the end. That should be the total amount. This is not the only way to do this, right? I'm not sure if they do what is it called? Posthumous? No, not humorous. Posthumously. If they posthumously divorce, I don't know if that's
Yeah,
possible.
posthumously divorced.
Yes.
Because you're already divorced, because it's still death do you part. You're already separated.
How many classes do you guys talk about ghost divorcing?
Hardly enough? Probably 2.
Oh, really? Okay.
Prenup can be, like, worked. Them shits are not foolproof.
Oh.
Yes.
Is it from the denominator? Where'd you get the times 24?
Life's experiences.
Oh, because that's the LCD for all the fractions.
Oh.
Here's the beautiful thing. If you have an equation with fractions in it, if you multiply the LCD, they all go away. All the denominators will cancel, right? Is that the only way to do number 10? No. But I think almost any other way would be gross. Am I gonna give you a problem just like number 10?
I have no idea.
Probably.
No.
Oh.
You're very unpredictable.
I know.
I was like, this seems like a
I'm
Jeff problem.
unpredictably unpredictable. I like that.
I like it your way, it makes me crazy. Like I just don't even wanna look at it, cause it just like confuses me so much.
Oh, okay. I'm
But I still want the same answer, but I don't know why.
Yeah, I'd love to see your reasoning, because I know there's other ways to solve it, but.
Yeah, so I don't know, I'm gonna talk to you after class.
Okay.
Usually to get. You know how you put 432,000 equals 24x? And then on the bottom.
No. 12x plus 8x plus 3x plus 432,000x equals 24x. Then I subtracted all the x's. What's 12x plus 8x plus 3x? 23x. So if I subtract 23x, I just get 1x left on the other side. So then x equals 432,000. So, guys, here's another way to do this problem. Just came up with it. If you don't want to use a variable,
Right.
you still have to work with the fractions, obviously. So half to the wife, 3/9 to the kids, 3/24 to the
Grandkids.
grandkids, and then
The rest that goes to charity.
there's 18,000 left over. Yes.
That's gonna be.
So real quick, add these together. So it's 1/2 plus 1/3 plus 1/8. Add those together. What do you get? So you have to get LCD, yes? Anybody know what the LCD is going to be? I already gave it away. It's 24. So this will be 12 over 24 plus 8 over 24 plus 3 over 24. What's that? 23/24 of the estate went to the kids, the wife, and the grandkids. So how much of the estate is $18,000 worth? 1/24 of the estate is 18,000. So what's the total estate? 24 times 18,000. You don't have to use a variable, right? I don't know if this makes sense. 1/24th of the estate must be the remaining 18,000 because all this shit was 23/24ths of it. 432,000. Yeah.
Oh, okay, that's all right.
Huh? Yeah.
Still too much money for that.
That's a lot more than a single double wide trailer.
That's true. That's true. He also had like 0.07 Bitcoin.
Oh, that's where it is.
0.007 Bitcoin.
I'm not leaving my kids to die. I just hope I raise them well enough to
Should be in
Shaquille O'Neal?
I guess number one, practice test three. I got 2 and she got 4, and she was explaining it to me, and I don't understand.
So, does this make sense? This problem says if P and Q are different primes, how many factors? So, inherently the problem is telling you it doesn't matter what the primes are. The answer will be the same. So if you need to, give yourself some numbers, 3 and 5. Yeah. 3 times 5. So you could just say that's 15, and then what are the factors of 15? 1, 3, 5, 15. It's got 4 factors, right? Now that's not what I intended the problem to be, but living within the constraints of the problem, that would be a valid way to do it. So how do I do this in general? You guys have to know this. If you break a problem down into its prime factors, is that still going?
Yes.
Barely, okay. Poor little battery's about to die. If I give you a number and I ask you how many factors does this number have, break it down into its prime parts. You have to know this. How do I figure out how many factors it's going to have? You don't want me to do it. It's not quite a link, but it's.
Why would go?
Huh? Sorry? Yeah, so who remembers how to do this? What do I do with the powers?
Add 1.
Add 1 and multiply. Yes. So it'll be 2 times 7 will have 8 factors. Why does that make sense? Because is 1 a factor of 40? Yes, and that's 5 to the 0 times 2 to the 0. Is 5 a factor of 40? Yes, that's 5 to the first times 2 to the 0. So for 5, it can either be to the 0 power or to the first power. That's 2 options. For the 2, it can be the 0, the first, the second, the third. That's 4 options, right? So for every one of these, there's 4 of those. 2 times 4, 8. Yeah.
So, just to try to get a different understanding, it specifies different primes. So if
Yep.
they're, let's say they were the same primes.
Yeah, okay,
that's
this is
not
good,
possible,
because
right?
I want to say something else about this kind of problem, but, yeah, if it's 3 times 3,
That's
how many factors does 3 times 3 have? 3, because 3 times 3 is 3 squared. And if you take every power and add 1 to it and multiply it by the other powers, you get 3. So every perfect square is going to have it in itself as a factor, and that's why it's got less than it normally would. Now, real quick, what about this? 12 squared times 8, times 25 squared. How many factors will that have? 9 is not correct. So there's a problem in the homework like this. Have I broken that down all the way? Is 12 a prime?
No.
What's 12? 3 times 2 squared, is that cool? 25 is 5 times 5 squared, yes? So isn't this 3 squared times 2 to the 4th times 5 to the 4th? So how many factors does this have? 3 times 5 times 5. 75 factors. There's a problem in the homework, at least one problem in the homework like this. So before you can do the trick with adding 1 to the power, you have to break the numbers all the way down. These numbers have not been broken all the way down. Y'all agree with me? 3 times 4 is 12? And then 3 squared, 2 squared squared is 2 to the 4th. 5 squared squared is 5 to the 4th. So this would be 2 plus 1 times 4 plus 1 times 4 plus 1. 75. Whatever that number is, would you all agree it's big? 12 squared times 25 squared.
Fairly large.
That's big. That's large. So it's gonna have a lot of factors. 75 factors, that's a lot. Shit.
It's also not that big. It's only 90,000.
Very warm in this room. I'll put that. By the way, guys, real quick, can you give me one way to factor 48?
24 and 2.
I could then build other factors using this, yes? I could make this 8 times 3 times 2, so this would be 8 times 6 is also 48, right? So I can recombine factors to make other factors, yes? Okay. I forgot my point with somehow I was gonna relate that to that. I forgot what that was.
Just blankly staring.
Huh?
I'm blankly staring at you.
Oh,
Just like, huh?
I understand.
Do we have to know all the rules by heart?
The divisibility?
Yeah.
Yes.
I think it's, you have to know 1, 2, 3, 4,
Four,
6,
5,
5,
6,
8.
8.
3
9.
and 6 are the similar ones.
Well,
Six
6
is 2
even
and
and
3.
3. 3 and 9 are the
9
similar
are the
ones.
similar
Yeah.
Yeah.
9? They're almost the same.
Bullshit.
6 and 2, or 6 and 3, like.
Huh?
6 is both 2 and
Alright.
3.
For 6 to work, 3's gotta work and 2's gotta work.
Okay.
So it's gotta be, all the digits have to add up to multiple 3 and it's gotta be even.
And, okay,
Yeah.
The one that I showed you is 4.
The last 2 numbers have to be divisible by 4, right?
And then you said something about like, something.
Since 4 goes into 100, that's why that makes sense. Guys, give me a relatively big number that 4 goes into.
7,000.
88.
So 7,000 is true. Does 4 go into 7,012?
Yes.
No thought required, yes?
Yes.
Because it goes into 7,000 and 12.
And 4 is true.
That is really not the full proof or anything, but that's why I only have to care about the last 2 digits.
For sure.
4 will go into 88,300, yes? So 4 will go to 88,304, 4 will go to 88,312, or, yeah. So I just have to worry about the last 2 digits. You're good.
Are we?
You're good.
Yeah. You're gonna know how to
So
do
in
that.
general, this is college.
I thought we were done. No, I get that. I thought we were.
No, I'm sorry.
I missed
Yeah,
that
yeah.
room. My bad.
I like that reaction. You were like,
Yeah, that's how
All the stuff 7 did you right?
no, we got
It's
through
7-2, I'm pretty sure. Yeah.
7-2, yes.
Yay! It take me like almost 2-3 hours.
Okay.
Dude, I'm still.
Somebody else is like, it only takes you 3 hours.
5.2 to 7.2.
5.1
What
to 7.2, yes.
So just 7-1 and 7-2.
What?
Your chapter.
From Yeah, so far, we're gonna do 7.3, 7.4 later, but,
Okay, but
so the test is from 5.1 to 7.2.
Got it.
I made one person's day.
You
That's
make
all I need.
our
As a
days.
math teacher, that's all I need. If I can make one person's day, that's
Yeah.
more than normal.
No, you literally made my day. I was about to sit in my car and do homework because I have another class, and I have class in the morning, so I don't want to forget when I get home.
I understand. The struggle is real.
Struggle is real.
I understand. So, as always, some of you guys do go to the Math Study Center for help. Math Science Center, gotta remember to say that. I always have my office hours, so you can always come by to see me. Because I know not every tutor is comfortable tutoring 125. What happened? Yeah, so in general, just don't hold back about questions. I mean, I think I told you guys a while back that my job, one of my most important jobs, is keeping us on track. So never self-censor about, don't say racist or whatever. But don't self-censor in terms of asking questions. Don't, because I always have students who are like, I didn't ask because I didn't want to. No, stop. That sentence makes no sense. You ask until I say, everybody else I got to see after whatever. That's my job. Yeah.
I just remember the conversation we had in one of the previous classes about Math 126, Math 126.
Oh yeah. Did you guys didn't I send something out?
She replied back to me. She said that they don't get enough kids to offer it more than once a year.
Okay, sure. But I'm not sure if they've ever gotten a lot of emails from students, so that's how they know. So, back in the past, we tried to run it every semester. And to be really honest, I kind of lost touch of how often we're doing it, but I didn't realize we were just doing it once a year now. And back then, we saw there wasn't enough demand. We would run it, it wouldn't run because we only had 7 students sign up for it, and our dean said that's not enough. Shop.
Is 7 students not enough?
Huh? 7.
That's not enough.
7's not enough. No.
What's
That's like
isn't
my
it like
dream class.
15?
Maybe for us, because our cap is 30, and they normally do 20%.
I know, but
So,
7
5
students
would
in
not be.
class would be perfect for me.
That'd be amazing.
Yeah.
But guys, reality, community college. Real quick, our budget was 1.9 million. In 2 years, it's going to be 800,000
What?
because of something called performance funding. There's anyway, it's a long story.
Did you say
So we're going to lose 800,000, but still, that's a big drop down.
Yeah.
So we are tightening up like crazy, and unfortunately, according to me, I think we're tightening up in all the wrong places. They're always eyeing our tutoring program, for example. They're always like, I don't know, and they're like,
Money.
I'm like, put money where the students are actually getting help, because guess what, we're freaking college, but you know.
And students getting paid.
Anyway, sorry. All that's beside the point. So yeah, there you go. That's where we are. Anything else?
Where is all the budget going?
Administration, unfortunately.
Oh yeah, duh.
So I probably shouldn't be saying this on recorded line,
I just ended that little part out.
It's going to the war.
Beep.
but over the last 12 years, the number of administrative positions in the district have gone up by about 25-30% at least, with no real apparent
Reason?
improved outcome anywhere. So, yeah. Anyway, sorry. We just had a discussion about budget, and they were asking faculty to do certain things, give up certain things, and we're like, can you do that with administrators?
What was the most ridiculous one they told you to give up?
Well, just like giving up the possibility of teaching a class in the summer, giving up, and some teachers can't give that up, and then they're forced to go elsewhere, and we're all scrambling, which is understandable. Anyway, I'm not gonna. I've already gotten into it too much.